Hey, welcome to part 2 of today's lecture, Friday. And we're going to be starting in chapter E5, and we're going to discuss density. Density is a unique property of matter. Matter is anything that takes up space and occupies volume. And property is a unique characteristic of a sample of matter. What we're going to discuss a little bit later in this section today is how we classify matter. So when we classify matter, we learn more about that sample, and we'll be discussing that a little bit later. Density itself is used to identification purposes. The density of a sample, again, is a unique characteristic, and we can use to identify what a sample of matter is if we know something about its density. Density is also used for measurement purposes. Liquids are best measured using volumes. If we know the mass and we know the density and we know the volume, well, we might want to figure out one or the other. So we're going to show how we can use density to help us determine what mass of a volume of a liquid we're delivering if we know its volume and its density. Density is defined as mass over volume. The units of mass are typically going to be grams, kilograms, milligrams, any type of mass unit. Volume are typically listed in milliliters for liquids, liters for gases, cubic centimeters for solids. Let's go over how we can actually calculate the density if we're given information about a sample of matter. So this is a sample problem I have prepared for you. There are similar problems in your textbook. This sample gives us information, and from the information it's given, we're going to calculate the density of a solid. So this example is giving us some dimensions of a cube. So example, a metal cube has a side length of 1.14 centimeters. And it has a mass of 6.67 grams. What's its density? Okay. Again, this is a word problem. It has a lot of information given to us. And what we're going to try to do is answer a question. So question is, what's the density? That's a big question here. What's the cube's density? So we want to figure out density. And when we're starting this problem, let's look at what's given to us. That's what we want. What's the density? Let's put a question mark by it. What's given? We're given that it's a cube. Pictures help. A cube is composed of equal sides, and in this case, equal side lengths. This one has a length of 1.14 centimeters. Okay? And then we also know its mass. .67 grams. And now we have to find out what's the cube's density. That's the big question. Let's write down the definition of what density is. Density is defined as the sample's mass divided by the sample's volume. So we're given the mass, 6.67 grams. How do we determine the volume of the cube if we know what the length of one of its sides are? So you can stop the video, go through this problem if you want. Okay, that's it. I'm going to go through the answer now. Now, remember what I said about a cube. I think we did this on our first day. The volume of a cube is defined as its length times length times length, or the length raised to the third power. So all we need to do is raise 1.14 centimeters to the third power, and that'll tell us the volume of the cube. If you put that into your calculator, we're going to treat this as an intermediate step. We're going to use all the data that our calculator gives us. If I put this into my calculator, we would get a volume of 1.48 1544, and the units centimeter are now cubed also. 1.48 1544 cubic centimeters. Let's put that into our definition for density. The mass is 6.67 grams. The volume we've just determined by taking the length and cubing it, and we're retaining all of our data. And now we're going to plug that into our calculator. We're going to get an answer, and our answer is limited in this case by a certain number of significant figures. Notice both the mass and the volume only have 3 significant figures. Our answer can only have 3 significant figures. The answer that we would report, 4.50. And remember, when we're given information and data, we need to have units. The units that we would use, grams over cubic centimeters. And we would write them as a quotient. Grams over cubic centimeters. And there's the density of that metal cube. Now, this would be useful for identifying it. And what we're going to show later in this chapter, later today, hopefully, is how we can use density as a conversion factor when we're solving problems. So that's important also. Now, the final topic that we're going to cover in section E5, as we began to discuss at the very beginning, was classification of properties of matter. We said that density is a unique characteristic of a sample of matter, and we can use it for identifying a sample of matter. Chemists want to learn as much as we can about matter. And one way we learn about matter is classifying the properties of it. One way we'll be learning about classifying matter a lot more when we move into chapter 1 and beyond. But today we're going to introduce how we classify matter based upon its size. And we're going to introduce intensive and extensive properties. Intensive, IN is very important. An intensive property is a property of the sample of matter that's independent of its size. Extensive property depends upon size. So, simple example. how we can recognize an intensive or an extensive property. We're going to take 2 beakers full of water. H2O is how we represent water. The chemical symbol of water is H2O. And these 2 samples are 50 milliliter beakers, and that's its volume. Each of them are 50 milliliters. And another property of them is temperature. That's important property, temperature. The temperature of each beaker is 20 degrees Celsius. Let's add them together. Let's add them. If we add them together, we get 1 large beaker filled with H2O. The volume when we add them is 100 milliliters. So volume depends upon the size of the sample. When we add 2 smaller samples together, the volumes are additive and we end up with a larger sample. That's an extensive property. Temperature. Now, if we add 2 beakers and they're both at 20 degrees Celsius, is their temperature going to double too? That doesn't happen. If they're both at 20 and we add them together, when they're all done, still 20 degrees Celsius. Volume is an extensive property. Temperature is independent of the size. It's an intensive property. So these are examples of how we classify matter based upon their dependence upon size or if they're independent of size. Some other extensive properties would include mass and length. Intensive properties, temperature was one of them. We're going to learn later that boiling point and melting point for any sample is also an intensive property. Regardless of the sample size, a sample of water, for instance, always boils at 100 degrees Celsius, and water always freezes at 0 degrees Celsius. That's an intensive property of water. How about density? My question is density. What do you think about density? Density, is it an intensive property or an extensive property? Stop the video and think about it. So let's start it up. Start up the video again. Density. So density is a ratio of mass over volume. So what happens if we have an object, that cube that we discussed earlier? Remember the cube that we had a few minutes ago when we were discussing it? What if we cut that in half? If we cut that cube in half, what happens to the cube's mass? The mass is going to be half of what it was originally. If we cut it in half, exactly, the mass is reduced by 1/2. The volume will be 1/2 of the original volume. What happens to the density? Density is going to remain constant. So density is a quotient of 2 extensive properties. Density is an intensive property. So if you have a sample of water at 4 degrees Celsius, it's going to have a density of about 1 gram per milliliter, regardless of if it's a swimming pool full of water or if it's a cup full of water. And I'm talking about pure water. So Density is an intensive property. It's independent of sample size. We're going to go into classifying matter based upon its composition a little bit more in chapter 1, and we'll understand a little bit more about some of the other properties a little bit later when we talk about chemical and physical properties. But today, the only properties that we're concerned with are properties based upon a sample size. So we're going to finish chapter E and hopefully in another part of this lecture. If not, we'll just finish it up on Monday, dealing with problem solving. Hey, thanks a lot. If I don't see you later today, have a nice weekend.